Given a point on the terminal side of an angle in standard position, determine the exact values of the 6 trigonometric functions of the angle. That's what this video is about. So looking at number 5, we're given the point 5, negative 12. Let's go ahead and sketch where that point would be. So let's do a little sketch over here off to the side. The important thing is the quadrant in which it will fall. So 5, negative 12, that's right 5, down 12. So if I went right 5 and down 12, and this is just a rough sketch, so you can imagine that this is the point 5, negative 12. And if so, then let's build a triangle out of it. Alright, so this is going to be the hypotenuse of a right triangle, and then I'm going to form the triangle against the x-axis. So if I do that, then this side of the triangle is length 5. This side is the 12. Because it's down 12, I'm going to go ahead and include that sign. That's going to allow me a shortcut. So if I look at this reference angle here, I can call it R. As long as I use the signs on these numbers, like the positive 5 and negative 12, if I find the sine, cosine, tangent, etc. of R, that's going to be the same as the sine, cosine, and tangent of the real angle, which actually goes like this. Alright, the real angle in standard position looks like this. Alright, it doesn't go like that. But no matter. I will need the hypotenuse. So to find that, I need to do the Pythagorean Theorem real quick. So let's see. So I'm going to just call this H for hypotenuse. So what I will do is a squared plus b squared equals c squared. So that's 5 squared plus negative 12 squared is equal to the hypotenuse squared. So that's 25 plus 144 is equal to the hypotenuse squared. So that's going to be 169. And if I take the square root of both sides, that tells me that the hypotenuse is actually 13. So let's go ahead and put that into the picture. So now I have all 3 sides of this triangle. So I should be able to easily write down all 6 trig functions. So I will do the sine of R. The sine is opposite over adjacent. Why did I say that? The sine is opposite over hypotenuse. Just spaced out for a second there. So that's negative 12 over 13. The cosine is going to be adjacent over hypotenuse. So that's going to be 5 over 13. And the tangent is opposite over adjacent, so that's going to be negative 12 over 5. Now, I'm putting all these r's because that matches the picture. The true angle, which in standard position would look like this, we usually call theta. And that's going to be the same thing. So I'm going to go back and use our usual theta instead. Alright, because as long as I'm using the negative sign, then I'm really finding theta, not r. Okay, anyway, back to business. So the other 3 trig functions are the reciprocal ones. The reciprocal of sine is called cosecant. So cosecant is going to be negative 13 over 12. The reciprocal of cosine is called secant. So that's going to be 13 over 5. And the reciprocal of tangent is called cotangent. So that's going to be negative 5 over 12. So that's how you do it. Alright, let's do another one. You should stop the video and try to do this one by yourself. Okay, negative 4 comma 10. So that's like left 4 up 10. So my sketch is going to be like this. Okay, so you can imagine that this is the point negative 4. What is happening with this? That is so weird. I've never seen that before. Okay, anyway, hope it doesn't happen with everything I draw now. Alright, so here's my little sketch. I'm going to make it into a triangle like you do. Let me see if I can fix this. Alright, since this is the point negative 4 comma 10, then this is left 4 and up 10. Okay, I need to know the length of the hypotenuse, so I will have to do the Pythagorean Theorem. Alright, I'm going to call this C. So C squared is going to equal A squared plus B squared. So C squared is going to equal 16 plus 100. So C squared is going to equal 116. To find the answer, of course, I will do the square root of both sides. So you can call C the square root of 116, or you can call it 2 radical 29, because that's the same thing. I think just to keep it simple, and since we're not supposed to be using a scientific calculator, I'm just going to keep it as the square root of 116. And just understand that some of the expressions I'm going to come up with could be simplified a bit more, but I'm not going to bother with that. So let's see. So I can now do all of the functions. So if I want to do sine, okay, and looking at this angle right here, but using these numbers, it'll actually be theta. Sine of r would be opposite over hypotenuse, so that would be 10 over radical 116. Okay, cosine is going to be adjacent over hypotenuse, so that would be negative 4 over radical 116. And tangent is going to be opposite over adjacent, so that's going to be 10 over negative 4. Now I'm going to reduce this one because that would be 5 over 2. Now if you wanted to simplify radical 116 without using a fancy calculator, only a 4-function calculator, you'd have to find a perfect square like 4 or 9 or 25 that divides evenly into this. 4 would be a good place to start. So pretend this is a 4-function calculator and do 116 divided by 4. So notice 4 goes in evenly 29 times. Okay, so that means that 116 is the same thing as 4 times 29. So if I take the square root of 4, that's going to become 2, and the radical 29 is left behind. So that's what's happening. So if I did want to reduce all of these, then I could replace radical 116 with 2 radical 29. Now notice that 2 goes into 10 5 times, so this would be the same thing as 5 over radical 29. 2 goes into 4 twice, so this would be the same thing as negative 2 over radical 29. Alright, so this is what it would look like as a simplified answer. So now it's time for all the reciprocal trig functions. The reciprocal of sine is cosecant. So that would be radical 29 over 5. Reciprocal of cosine is secant. So that would be negative radical 29 over 2. And the reciprocal of tangent is cotangent. And that would be negative 2 over 5. So that's how you do this.